Hi, so this is our second video on modeling motion with vectors. So in example 2, we're told that at time t equals 0, the particle P is at the point with position vector 2, 6 and moving with constant velocity 1, 2 meters per second. A second particle Q is at the point with position vector 10, 6 and moving with velocity xy meters per second. After 4 seconds, P and Q collide. We've been asked to work out the point of collision and to find the speed of Q at the moment of collision. So if we begin by considering particle P, we've been given the initial position and its velocity and the time of 4 seconds. So from this, we can use this formula, which we found out in example 1, to find its position at 4 seconds. So R4 will be equal to the initial position, 2, 6, plus time, 4 seconds, multiplied by its velocity, 1, 2. We can expand this out and we get 2, 6 plus 4, 8. So now we can add the I components together, we get 6, and then for the j components, 14. So this will be 6i plus 14 j meters. So we know that this is the point of collision, but this is also the position of Q after 4 seconds. So considering Q, we know that after 4 seconds, the position will be 6i plus 14j. We know the initial position is given as 10i and 6j. The time is still 4 seconds, and velocity is now xy. Well, we can work out x and y by moving this vector to the left-hand side, and then setting up an equation involving the I and j components. So therefore, moving this over to the left-hand side, we'll have negative 4, 8, will equal 4x for the I and 4y for the j direction. Solving these equations, negative 4 will equal 4x, so x must equal negative 1, and 8 plus, or 8 is equal to 4y, so y must equal 2. So we know the velocity of q then will be negative I plus 2j meters per second. But to work out the speed, well, speed is the magnitude of velocity. So this will be the square root of negative 1 squared plus the 2 squared, which is root 5 meters per second. Okay? And in the next video, we'll be looking at when we use displacement to replace the VT.